Alright, hi guys. We're going to go through predicting products a little bit more, just giving you a little bit more background and information. Again, don't be afraid to use your textbook. I believe we're in chapter 10. There's lots of example problems that you can look at. Use Miss Sekle, YouTube, Google search, anything like that if you're still having problems, okay? So predicting products, start on the correct slide here. This is going to be a continuum of our types of chemical reactions notes. So when you're trying to predict the product, basically what you're doing is you're kind of guessing which type of reaction is going to make the most sense, and I'm going to break that down for you. It's always best to start with the simplest solution and work your way up if you can't solve that solution, okay? But you do need to look at basically what's being given to you and try to use deductive reasoning to come up with the solution, okay? With predicting products, the first thing you're going to do is you're going to come up with the product, and that's where your ionic and covalent bonding comes into play. That's where your charges, your number of valence electrons, all of that. So basically everything from last semester and this semester come together to help you basically make your products, and then you have to balance the equation. So it's kind of like taking everything and putting it together. Okay, so we're going to go through, we're going to do a couple examples of each from one of your previous worksheets, and then there will be some example problems on your review guide also, so you can utilize what you're learning. Alright, so first thing, if there are two or more single elements on the reactant side, then they are going to come together to become a single compound. Okay, this is if it's a combination reaction. So I'm going to pull up our more predicting products worksheet. Okay, so combination, let me find where the combination is. Oh, gotta go up here. Alright, so again, we're taking what we learned from last unit. So we've got magnesium plus oxygen, and if it's oxygen, remember oxygen gas is O2. Okay, so magnesium, according to our periodic table, is going to be a charge of +2, so it's a cation. Okay, oxygen is going to be a charge of -2 because it's an anion. Okay. So if we have magnesium and we have oxygen, our final product, because this is a combustion reaction, is going to be MgO. Okay, so combustion because there's just one single element on each side. Now, I know you're probably thinking, well, O2 is not a single element, Miss Davis, yet remember it's a diatomic element. Okay, O2 only exists in nature as two oxygen molecules put together. So it's still one single capital letter. So you've got element 1 and element 2, which would give you compound 1. Okay, now looking at this, so we know that this is a combustion reaction, or excuse me, not a combination reaction. So I'm going to put combine here. Okay, now, is this equation balanced? Alright, so we've got magnesium, we've got oxygen, we've got magnesium, we've got oxygen. Okay. We have two oxygens here. We've got 1 and 1. Okay. So we can see right away oxygen that's not balanced. So we first need to start by giving our coefficient. So that's going to turn each of these into 2. Okay, so now we need to put a coefficient of 2 in front of magnesium. Everything is balanced. That is a combination reaction. Okay, so you took two single elements, you put them together, and you made one single compound with that. So coming back over. Next thing, if there's only one compound on the reactant side, that will split into two or more elements or smaller compounds. So decomposition kind of gets a little bit more challenging. So we'll come over here. Okay. So here's our decomposition. So we have one single element on our reactant side. So we need to split that into the two elements on the product side. So looking at our equation, so we split this into barium and iodine. Okay, so we go ahead and split it down the middle. And we've got barium, iodine, barium, iodine. Okay, over here, barium, we've got 1, iodine, we have 2, barium 1, iodine, we have 1. So we'd see here, this is where it's off. We're going to go ahead and give it a coefficient of 2. Okay, and that problem is done. Okay. So I'm going to go ahead and erase this so I can get to the other stuff here. Okay. Alright, so moving on. Now, probably the most challenging product prediction that there is going to be single displacement. And the reason for that is because when you have a single displacement, you have to figure out, is the single element a cation or is it an anion? Because it can only replace the similar element of the compound. So if there's a compound and a single element on the reactant side, the single element will replace the element in the compound of the same kind. So the cation will either replace the cation in the compound, or if it's an anion, it'll replace the anion. Okay, so let's come back up here to our single displacement. So let's say, for example, that element C here is a cation, and element B is also a cation. C is going to replace B. Okay, that's the only way that works. Alright, so an example of single displacement. We come back over here to our problems here. This is on the second sheet. So I have number 3 on the second sheet labeled as single displacement. Okay, so again, we have one element on the left-hand side of the reactant, and then we have some sort of compound. Now this one does also feature an polyatomic. Okay, so remember, keep those together. We like to keep those together. Makes your life easier. Okay, so first things first, we got to look at iron, and we have to determine, is this going to be a cation or an anion? And we know that because iron is a metal, it's actually going to be a cation. Okay, and then copper, we also know copper, because it's a metal, is going to be the cation. So iron and copper are going to switch places. Okay. CO3, the carbonate, that's not going to be, it's not going to switch because it's the only anion, so it needs to make sure we have those equations balanced. So we've got copper plus iron carbonate. Carbonate has a charge of -3, and one of iron's options is to be a +3. So again, we're going to start simple. We're just going to assume that because carbonate's charge is -3, that we're going to use the +3 iron. Just makes everything easier, so you don't have to worry about making it +2 and having to balance it. So looking at this equation, on the left-hand side, we have one iron. We have one iron on the product side. We have one copper. We have one copper on the product side, and we have one polyatomic ion of carbonate, and that same holds true on the product side. So this equation is actually balanced. Now, double displacement, if you have two compounds on the reactant side, then just go ahead and assume that the anions are going to switch partners. You don't really have to worry about the cations. Okay, so anions are going to switch partners. So if we look here, here's a double displacement example, because we've got two compounds. We've got silver nitrate plus chromium iodate. Okay, so again, we're just going to go ahead and assume that our anions are going to switch places. So our iodate's going to come over here with silver, and nitrate's going to come up to chromium. Chromium, let me think here, iodate has a charge. Iodate has a charge of -1. Okay, so we know that we have 2 of these -1s. Okay, so that means chromium must have a charge of +2. Okay, because we've got 2 of those -1s. That means this whole thing is -2. So we know that chromium's +2. Silver has a charge of, I believe, +3. Yes, which would make sense because nitrate is going to have a -3 charge. So, go ahead and write that in here. +3 -3. Alright, so again, our anions are going to switch. So now we have AgIO3. Okay, and we'll balance this all out here in a second. Plus chromium NO3. Alright, so chromium's got a +2, nitrate's got a -3, so we need to balance those out. So it's going to be chromium, chromium 3 NO3 2, and then silver, this should be good. So silver's +3, iodate's -1, so we need 3 of these. Alright, so then you need to balance your equation, looking at and comparing the reactant side to the product side, and you should, for your overall, I'm going to get rid of some of this so I can balance it. So we will need, I lined up the middle here, we've got silver, nitrate, chromium, iodate, silver, nitrate, chromium, iodate. I'm going to go ahead and pause the video, guys, so I can balance this without running out of time. 1 second. Alright, it's kind of messy here, but upon balancing it, we started off with 1 silver, 1 nitrate, 2 nitrates, then chromium, there's 1 on the product side, 3 on the reactant, or excuse me, 1 on the reactant side, 3 on the product side. Iodate, there was 2 on the reactant side and 3 on the product side. So when we balance it out, what we finally get is 2 silver nitrates plus 3 chromium iodates yields 2 silver iodates plus chromium nitrate. Okay. Now, finally, the last one is going to be a combustion reaction. Super easy. Okay, if on the reactant side you have nothing but a hydrocarbon, which is just carbon and hydrogen put together in some way, shape, or form. It can be C6H12, it can be C100, H600, it doesn't matter. As long as it has a carbon-hydrogen compound and oxygen gas, the reaction will be water and carbon dioxide, and that's all you'll get. Okay, so if we come back over here, erase some of this stuff. Here we have a a reactant of C2H6. So there's our hydrocarbon. There's our oxygen gas. We know for sure we're going to get H2O and CO2 out of the deal. Now we just need to balance. Alright, so balancing, we have carbon, hydrogen, oxygen. We have carbon, hydrogen, oxygen. On the left-hand side, we've got 2 carbons, 6 hydrogens, 2 oxygens. The product side, we've got 1 carbon, 2 hydrogens, and then we have 3 oxygens. Okay, so be very careful with that. My best advice to you would be start with these 2 here with the oxygens. Just makes life a little bit easier. Okay, so if we've got 2 on the, or excuse me, save the oxygens for later. Start with carbon and hydrogen. So if we've got, so we need to do our coefficient of 2 over here, 2. Okay, but now we have oxygen is going to be multiplied. So let's go ahead and multiply this by 3, just because then we got 6 over here. Alright, so now we've got 3, so now we've got 7. So what we can do here is 2 multiplied by blank amount is going to equal 7. You can either mess around with the numbers more, or you can I'm going to run out of time.